This video will introduce the application of nanoparticle using as contrast agent in medical imaging. Before we started, let's talk about what is nanoparticle. What are nanoparticles? We will find the answer for that in the next few minutes. Simply, nanoparticles are extremely small particles. If you compare the diameter of nanoparticles to the diameter of the soccer ball, it is like comparing the diameter of the soccer ball to the diameter of the Earth. According to the International Union of Pure and Applied Chemistry, a particle of any shape with the dimension in the range of 1 nanometer to 100 nanometers can be identified as a nanoparticle. So why are nanoparticles important? Because they show very different physical and chemical properties, such as optical, electrical, mechanical, magnetic, and catalytic properties compared to the above counterparts. For example, we can see gold coins in gold color, but gold nanoparticles have different colors. The color of any material depends on how the material interacts with the incoming light. When the light interacts with bulk materials, the amount of reflected, scattered, absorbed, and transmitted light decide the color we see and is unique for the material itself. For example, if you have several gold coins and bars with different sizes, all of them will be gold in color. Similarly, if you have several silver coins and bars with different sizes, all of them will be silver in color. However, when light interacts with nanoparticles, the amount of reflected, scattered, absorbed, and transmitted light not only depend on the material, but also on the size, shape, and the surrounding medium of the nanoparticles. That's why different gold nanoparticles have different colors. But remember, we only see this color for the nanoparticles that interact with the visible range of the electromagnetic spectrum. The differences in melting points is another example. Melting points of the bulk material doesn't depend on the size of the particles. However, at nanoscale, melting points depends on the size of the nanoparticles. The smaller the nanoparticles, the lower the melting point. This phenomena is known as melting point depression. So now you know that size and shape matter at nanoscale. Different sizes and shapes of nanoparticles of the same material show different physical and chemical properties. Due to these different properties, nanoparticles are used in almost all fields of science. They also have a wide variety of application in industries such as textiles, pharmaceutical, cosmetics, electronics, and even food. You currently benefit from different types of nanoparticles, and in the future, you will be benefit from them more and more. One of the most important applications is nanoparticles are being developed for diagnostic imaging, for the early detection of neurological disease, cardiovascular disease, and cancer. The technology is based upon contrast nanoparticles, which can be metallic, magnetic, or polymeric in nature. These particles can be functionalized with a biological targeting agent, such as an antibody, and are generally between 10 and 100 nanometers in diameter. For the detection of cardiovascular disease, the contrast nanoparticles are introduced into the bloodstream. In this example, the particles are targeted towards proteins on the surface of an atherosclerotic plaque. These plaques can lead to blockage of arteries, resulting in events such as strokes or heart attacks. When the particles bind to the plaque, high loading of the particles can be achieved due to their small size. Thank you for watching this video.